part called as projections of solids. So in projections of lines, we were talking about the true length of the line, angle made by the line with horizontal plane, angle made by the line with vertical plane. And truly speaking, if you understand projections of lines very well, probably any of these further topics like projections of planes, projections of solids, sections of solids and development, none of them are to be taught in the class, because everything will be based on the projections of lines. If the projection of line is conceptually totally clear, then projections of lines itself will give us the projections of planes, because when we talk of some plane, say a rectangle which is kept on the horizontal plane, then the 4 points of the rectangle, which are namely A, B, C, D, they will have their elevations on XY line, giving us projections of plane in its elevation form as a straight line which is on XY. Now observe that line AB, which I have drawn perpendicular to XY, will be seen in point view. And this particular line is parallel to horizontal plane because it is in horizontal plane. So obviously in the top view you can see the true length of the line AB, and the front view of that particular line is on XY, which is a point view. If we consider line BC, then that line BC, as its plan is parallel to XY, we can say that the line is parallel to vertical plane. And also it is being in HP, it is parallel to HP, so its elevation will be parallel to XY, that is B dash C dash, which is on XY itself, because distance from horizontal plane which will be seen in the elevation is 0, and so BC will be seen in its true length, as well as even in elevation it will be seen as true length. And if we continue in this form, then we find that all the lines are seen in true length in the plan, and the corresponding front view is on XY. Now this is in relation to the projections of lines only. When we go for the true shape of the plane in horizontal plane, or rather in plan or in elevation, obviously we are talking about the projections of lines. Only thing is, these lines are going to bear some relation among themselves, like over here these sides are perpendicular to each other, and that's why their projections also will be related to each other. Because line AB and line BC, when we consider, point B is common among them, and that's why it will be completing projections of line AB, and related to that you are required to find out projections of line BC. Now when projections of planes is considered, at the second stage we were talking about the plane inclined to, say, horizontal plane. In that case we have said that the line of rotation should be perpendicular to XY, and suppose this rectangular lamina itself, if I plan to turn about line AB, now here I will be calling the plan as A1, B1, C1, D1, and obviously the elevation will be A1 dash, B1 dash, C1 dash and D1 dash. And suppose angle made by the plane with horizontal plane is given as some 40 degrees, then this line view gets rotated by 40 degrees, giving us points C dash, D dash being their final position. This will be the final line view, and A dash or A1 dash, B1 dash themselves will become A dash, B dash. We are dropping the projector from point C and D in the elevation, and we can complete the plan, which will be A, B, C and D, remembering the fact that rotation in one view is movement parallel to XY